started. Let's play. Some music. Guess I don't have the one I've been liking. Oh, it's in this folder. All right. So my goal now is to implement everything I was thinking about before lunch, and it's a lot of stuff. So I'm gonna do kind of lock in and focus mode. If I see someone in the chat, I will re-explain that I'm in lock in and focus mode. But otherwise, I'm gonna be kind of quiet and just going through this. The steps are: one, I've got to rewrite the rules of the game again in a new format that matches this idea of a machine being a thing with a context, and then a rule having a preamble, and then the moves run, and then a postamble. And then we need a machine stack to go second. So I rewrite the rules, and then it'll all be broken, and then I make it work, right? But before any of that can happen, we're gonna do make it work first because I broke everything a bit ago. So I'm just gonna like kind of get us back to a baseline of working before anything else happens. So to do that, I think all I gotta do is, let's see, get this like this, get this like this. I think that's about everything I changed. Great, okay. Now, let me check that in. Oops, wrong one. Get. Okay. So that should thoroughly break what we had. Now let's look at the encounter rules and try to fix some things up. This, first of all, needs to be phrased as something like encounter context now. I think these are going to go away. Okay. way this works is we do something like... We're not going to need that anymore, I don't think. Okay, so somehow I need to phrase the fixed moves thing to work. So you get the subcontext. We're not going to do any of this. What we're going to do is we're going to go we're going to say pick one. So I just list out the decisions that need to get made, like this. Except, if you want this to run as fast as possible, in bot brain mode, you would want to have some extra stuff in here. Like you'd want to say, this we're doing for a user interface, right? But for the bot brain, we're going to have to go back to this. The bot brain's going to use the states directly. And all of this is now unnecessary. So it sort of feels like I'm going to want to have a split between, like, I want to be able to say this code only needs to run if we're doing the, like, bigger interface generation for at least one human player. For a couple of bot brains, you could actually skip the preamble because the bot brains will be coded to already do the right thing. There's something like that possible. I don't know exactly how I want to think about it. But I list out in the pre any decisions that can be made. Then decisions will get made. Once they're made, moves will occur. And then same thing as up here. Okay. Thoughts. Okay. So we say which decisions we want you to make for each player. Rather, for each party. So this party picks a branch, this party picks a branch. Interface stuff happens. Moves occur. In this case, there are no moves submitted, so nothing in the move section happens. But the decisions happen. The information gets stuffed into P branches, and then we run the post amble, and the P branches becomes the go-to. Okay. Okay, to fight. Yeah, I don't think any of this is going to survive either. This is just a dummy. Fights might not, or encounters may not even need a context, but the travel definitely will. Gather up tile moves. Grant moves. This is all still the same. Although now this looks more silly. This could probably be more like... I don't know. That can probably be default. The moves actually get... We don't actually need to do the tile gather here. That's repeatable. So all we're really saying is how many moves we grant during the preamble. We'll get there. So by the time we get here, all of the moves have been run. So that means all of this is done. And so all that's left to do is if we got that far, we go back to the encounter. Ooh, this simplifies the rule system a lot. Like the rule code is now going to be kind of trivial. set up what decisions get made, automate the resolve, and since it's combat, a fight is like the simplest set of rules that the system has. There's nothing else to it. Okay. Okay, this part, it might make sense to say is like this. So we start by clearing out, initializing the speed sub game, fight and flee. The fleers get to make moves. Where's the, yes, quick actions only. So we assign moves for that party. And then they get run, which modifies their speed sub game. And then the encounter fight, encounter flee sub game. Final step is to do this part. Then we have a pre for flee chase. And notice here, the party that was fleeing here is now being sorted here. I find that confusing. So I'm going to reorder this one to be flee fight. So party 1, 0 party goes here. They're the flee party. We don't clear out. We just send out decisions to the chase party. They get the same kind of moves, but they're in the chase state instead of the flee state, which means just that there's an asymmetry to the outcomes based on who wins the chase. And then the post is, okay, grant the moves. That's handled automatically. All the moves have been run automatically. So now if you reach this point, you get a chase speed from each index, from each party, using the encounter context. Do some logging, speed 0, speed 1. Yeah, so then we just figure out which states we're going to. And then there's no temp. Okay. So I have a question. I see you switched to C a while ago. How do you deal with polymorphic functions without function overloading? I don't know what the question is. What do you, what's a polymorphic function? C11 generics suck and Hungarian notation drives me crazy. I don't know about C11 generics. I don't use generics. I don't use function overloading. I don't use default parameters. I don't use anything that would modify the interface that is bound to an identifier. In fact, I think even if I have them in C++, I don't want to use them. So if that's what you're asking, the answer is I don't deal with them. I think that they're a problem. I dismiss them from my systems. I'm a little unsure what you're asking though. It's been so long since I thought like other people about programming that I forget exactly why people like function overloading anymore. Like what is it? What is the problem? Help me remember. Okay, so in a flee scenario, what we do is we clear out the speed. And we assign moves to both parties. So I set the limits on both of them. And then the post is... That's automatic, that's automatic, that's automatic. Go to exit, exit. There we go. So that's the new rule scripting, I think. So the standard flow here is the preamble decides what moves need to be offered. Then an in-between period happens where some kind of interface or bot brain occurs to make the decisions, and then a post-amble, then a default resolution occurs, and then a post-amble rule-specific resolution occurs. Now, before I go and re-implement everything, let me do the same thing to this one. I don't know if I need that. We'll figure out what happens here. I'm going to just simplify until I see how everything else shakes out. So journey, round begin, pick a branch, go there. Journey. Here's our limit. So for each character in the party, that's all of this. That's automatic. That's automatic. And this is the post part. This is one of the things that I like about using C. It's happening right now, it feels like. Now, it might not last. I'll probably do this, and then a couple days later, I feel like I've once again hit this wall. But every time I sit here and think about, like, oh, maybe I'm wrong and I should use destructors to clean up scopes. Or maybe I'm wrong and I should use exceptions to unwind stacks. Or maybe I'm wrong and I should whatever. When I then stick with it and figure out a way to express it in C, what I am forced to do is to rearrange the system so that it truly does affect the system. It's not a phrasing thing. It affects what is possible and what is not. But somehow it also seems to align the things which are possible to express without a bunch of automation helping you are those things which are the most simple, straightforward, logical, consistent behaviors. Like, I almost think that it's better to have a language without features because features are bloat automation, and what you want is designs that don't require the bloat in the first place. And C does that every time. And that's what it feels like right here. It's like all the lines of code that we're helping to stitch this together and pretend like it's a scripting language, but there's all this like stuff aching at the edges. I could have just gone and made a hacked up scripting system. It's actually a scripting language with all these features, and it would have had the same structure that it already had. But by doing what I'm doing, the system has been changed to one that has basically the same effect that I want, but is much more streamlined conceptually, and everything's just falling into place. Like, I'm writing half as much code all of a sudden to make all these things happen. So, like, what happens when you finish travel? So travel, you get to pick some stuff, some moves, then possibly an encounter gets generated. Now I get to generate the entire counter here. This is the first time something interesting is happening, though, so let me not say too much. Here is where the call is happening. So instead of a go-to, it's a call, right? You see that? And yeah, Paging Turner's talking about there's this thing, Lego bricking, fat structing, product typing, whatever you want to call it. Designing a language, designing a vocabulary. I talked about this morning, not a programming language, a vocabulary. Designing a system of information units that relate to one another is the real task, it feels like. And it enables you to to capture the essence of a concept. Now, I'm not saying that C's feature set isn't also weird. Like for instance, the whole C scripting thing is me saying there are things that are missing, but they're not quite features that I've seen people doing. Is like, I don't want an automation. What I want is I want automatic organization. I don't want new stuff generated for me. I don't want automatic code generation of like destructor calls. I don't want automatic code generation of template instantiations. I don't want all this automatic code generation. What I want is code organization. I want code structuring. I want information relationship management features. Does that make sense? I feel like that's a way to describe what I like, the shift. Play. No. This one gets stuck in my head, and I'm just like, play it again. I'm trying to think of how I want to phrase this part, actually. I think that it still just necessitates that continuation setup, which is a little frustrating. Um, Player Anonymous, you're not the first person to ask me if this is vibe coding. It's a great question, but I wouldn't know because I don't really pay attention to what other people are talking about. I know this is kind of the sort of thing that I think if you say it too often, you start to sound like you got issues. But I think people are mostly full of shit, so I kind of keep to myself as far as programming stuff goes, you know? So there's the vibe. Is this a state, though? Or is it a handler of some kind? Do I want to say... I feel like I want a handler. Maybe what we want here is just a hook. So we make the call. We say when this call returns, here's how you're going to handle it. And so transitions of state seem to be happening primarily at like during the post-amble code and are allowed to happen during the shuffle and run moves phase of the loop. In theory, they could happen during the preamble too, but if they did, they would then interrupt the rest of the loop. There wouldn't be any shuffle and run moves. There wouldn't be any post-amble. But whenever it happens, I think it can happen anywhere. You're in the middle of a loop. What would happen is the handler would happen in that iteration of the loop. So you'd say, all right, we go to the exit state. Now that doesn't work because you go to a state and then you are done, right? Whatever caused you to go to a state, it caused you to be done with that iteration of the loop. You go and you see you have no handler. And then this is just going to be like this, I guess. So you go and you see that the machine you're in doesn't have a handler. You pop the stack, and you see that the machine underneath has a pop handler or something, right? When this is saying that if this comes to a state, right? We call into this machine. If this machine reaches a state without a handler that is built into the machine will halt. So the machine reaches an exit state, but that exit state means what you actually do is you then pop the machine off the stack, another machine takes over, and that machine may have a handler hooked up and ready to go. And if it should always have a handler hooked up and ready to go. If it's not hooked up and ready to go, then it's the same as if there was a no-op handler, right? Just a do-nothing handler is there. But either way, what that means is then you go, okay, here's the state we're in. You run this handler instantaneously. You say this overrides anything else. So after a halt state, the handler from the previous machine runs for one iteration. And that is different from a normal iteration because it's not a preamble or anything like that. It's just some additional resolution and state update, right? Could it be that that could want to be a state? Yes. But then what I would do is just right here, I would write, here's the handler go to, right? And I could have, set handler at state or whatever. Like I could have a helper or something. I don't know how about that. So we come back. We've got a state for two parties here. And what we want to do is be able to add. Here's how we generate the encounter. The final, this isn't just journey round end. This is like encounter end, journey, encounter, end. And what you do is you now have in RP, an RP count, right? So here we have, okay, this is going to be assert RP count equals 2. RP will have each of the party pointers, and RP states will have the states. So we'll have a return version of all the P values that are coming from this machine, whatever its final thing was. The states of this machine will still be in place, and so then I can say something like go to RPG. Let's just put the state in here, U32 state. RPG state journey round. Okay, so beginning of a journey round is the default. You go to encounter. When it's over, you keep on journeying. You make more choices about how to continue your journey. If you die, let's see. So this should be P or RP0. So RP0 is the RPG state dead. So if the player party ends up dead, they enter into the dead state, then we're going to pass dead along. Now, if that does not happen, you can imagine possible rewards for some encounters if RP state 1 has a particular value, right? So maybe Maria, welcome. I'm doing good today. Okay, this is gonna work, but I'm realizing that I want to add some more richness to the states that I return from different scenarios, right? So if the party ends up dead, then they're dead. There's another thing that might happen that's worth checking. If the party ends up in the encounter escape state, then I think what we do is we actually go to RPG state, journey, go back. So if you're on a journey and you flee at any point, you go back. That's like a penalty, right? That's a part of it. Maybe not, but that's like a possibility, right? I want to be able to program that as a possibility. That seems like a reasonable rule. It might be more like if you flee, you don't make forward progress, and so then there's this idea of like, okay, maybe it's not about this. Maybe the difference is if you are gonna make forward progress, what has to happen is you have to finish the encounter without fleeing. You can't turn tail. You have to either beat them or at least get past them somehow. Then let's see, where is this? The journey context. That's the one I want. Okay. Journey context is this one. Step count plus equals 1. So if you die, you don't make progress. If you escape the encounter, if you flee it, maybe it's like fled, you don't make progress. But any other exit state, so if you beat them or if you get past them at least, then you increment the step counter. You make forward progress on your journey. And then either way, you go to the state. So by default, you're going to do another round of the journey. Now, of course, there's another step here, which is like if subcontext step count equals, let's just hard code it for now. So let's say there's going to be 6 encounters on a journey. If you execute perfectly, you have an encounter, you beat it, you have an encounter, you beat it. Each one is a step forward. And so you have to make 6 steps forward, and that means you have to beat 6 encounters, right? It's just lockstep right now. The full plan might be that some steps come without an encounter, or that some steps, or that different modifiers might let you make more than one step over time. You know, if you've got a horse, maybe you can go 3 times faster and you make 3 steps on your journey instead of 1. I don't know. But once you've made enough steps to finish the encounter, that would actually be when you would do state equals RPG state exit. So that's when you exit out of the journey state or the journey machine, right? So this machine would then return to the overarching story that had you on that journey that is now going to take you to a boss fight for a quest or to a new town or whatever it is. The next level up in the hierarchy knows what that means. But we just say when we're on a journey, if you get to the end, then you're done and you exit. But only if your state is still, journey around. If somehow your step count gets large enough, somehow, but you also died or turned around at the same time, then we'll say that's not good enough. Something weird might have happened there. Maybe there's rules that let you increment the step count. I don't know. It probably should be impossible, but let's just say, logically speaking, you need to have actually been set up in such a way that you were going to keep journeying, but you got to the end. So that's how we end an encounter. We check to see some stuff about the state of one or both parties, update the state of the journey game, and then go to the next state, whether that be a state that exits, which is dead or exit, or a state that somehow continues the journey game. Man, this is cool though. This is starting to feel like I could rapidly iterate on the rules of something like Journey and fine tune it, tweak it. Like, do I really want fleeing to mean you have to go back, or does it just cost you the step? Does going back mean you have to go all the way back, or does it just mean you're decreasing your step count? Step by step. Does fleeing mean you just don't make progress and then you have the option to go back or camp or try again? So many possibilities, right? I don't know. Calls the encounter machine with these parameters. Okay, so Journey Camp, just the next thing you can do. We don't generate moves manually anymore. We don't do this, but we do iterate the characters. We don't care about the limit being there. Well, all we gotta do is go RPG, decision, moves. How does that look? Do I have one here? Yeah, moves, set the limit for those characters. That's gonna be so much simpler. That's automatic. That's automatic. That's automatic. That's the post-amble. That's out of here. RPG rule post, RPG state raw, journey camp. Hello, Zeus Mystic, asking, what is this? This is me fooling around having this project called the RPG Simulator. Basically, I'm programming the logic of an RPG without a video game interface attached. I mean, we also, you know, I haven't been working on this on stream. I did this a few weeks back on stream, but I do have like a set of assets that are from OpenArt that I've been playing with. So I might add a video game aspect to it. Like there might be a game someday, or there might at least be a video game style interface to it. But right now, all I've got is just the simulation of the logic with bots playing all sides, like all characters. And I'm building up things like the rules of first the turn-based combat, and then the uh, various meta games that contain that. It's a little hard to explain because I think it's a slightly odd concept. It's gonna be unique, I hope, if I get to show people how this sort of way of doing things works. Um, but it's been fun. And today we're just building out new. We're just building out some new simulation concepts, a new way to write the main rules of the sub games. Okay, so these are out. These go on the encounter context. That should work. How long have you been working at it, though? Okay. I've rewrote the journey rules with the new idea in mind, but I haven't implemented any of the new idea yet. So, next is the job to actually implement all these new constructs. All right, let's see here. How about, we do yellow. I feel like nobody will know that my lights are colored if I make them yellow, right? That passes for white somehow when it comes to light colors. I'm just kind of bored of using the white lights. All right, let's try this. So, okay. Yeah, we were in pure green. I could also set it to more of a cyan color. Now we really got those aquatic Atlantic vibe or Atlantean vibes for you. Yeah, orange shirt with green light was a very very odd choice for sure. The color I had this morning was red, which is kind of intense. It's like dark and moody here. But let's just do it this way. Okay, so rule scripts are super out. Something new is in, and that is the machine scripts. Machine. Let's just call them the machine definition. The machines. So a machine needs a machine proto. Let's see. Each machine has a hook, a type size, do I need a display name? I think that will be useful. So we'll do that. Then we make a symbol set called RPG Machine Symbols. And that's how you set it up. Machine proto. Machine. Mosh. That should do. And now what we want to do is we do need to use all those wrappers there. Because we don't... No, rule... Okay, so this won't be as hard as the rules. Okay, rule... machine... decal... N is going to be a symbol declare RPG machine symbols. N, that's how you declare a machine. And a machine definition is going to be... Let's see here. Function RPG hook signature RPG underscore underscore machine def underscore underscore N T. So we're going to use the type as the parameter in the machine function, right? That is typed like this. Oh yeah, Zeus Mystic. Sorry, I had a bunch of people show up and I wasn't going to respond. Don't. I understand the feeling of stuck. Here's if you want to, if you're here, and for anyone else who's here who might be checking out programming but isn't super invested in it yet and is wondering about it, let me just tell you what I think. I think programming is also total nonsense. Like everything is invented, right? So learn it because if you're interested in computing and you want to be a part of building things, or you got ideas you want to express with it, it's worth it. But don't take it on yourself when stuff seems weird and over complex, hard to grok, not intuitive. That's not your fault. That's because we haven't figured out how to build them right yet. And I'm not saying I know how to build them right. I'm just saying I'm not impressed with how we did it. There's got to be better ideas than what we have so far. So, just remember, you're learning a very crude, poorly understood concept that nobody really gets it. And the reason that it's so hard is because you're being taught by someone who thinks that they know the best way to program, or at least knows how to program, but really none of us really know what we're doing. We're still trying to figure out the right way to build this whole system. At least that's my hot take. And it also just takes a lot of time. That's true too. It takes a lot of time to, especially if you're learning by yourself, because you care about it. And you're just gonna have to grind through so many things to be able to fully express yourself with the tools of computing. Now, something that sucks here is that in order to construct this, I'm gonna end up having to put two arrays down a bunch of times. You see that? And it kind of makes me think that maybe I should go about this a little differently. Maybe I should be doing something like RPG rule, def, and grab these and then give it a name, right? So this is like the encounter round rule. And the fact that encounters have this double state thing, it's really cool, but it's kind of small, and I don't think it's going to scale to that many other systems. Like I'm in between whether or not that's a good or bad idea, right? Because the upside is that now it generalizes, but the downside is I don't think that many things actually want it. I think most things want one state for one party, like the journey system. I think encounter being at the core of the simulation, being the thing that handles two, is going to actually end up being the only thing that handles two. But we could just do it like this. We could go. All right, so it's U64 raw states, right? And then you go like in RPG encounter round equals this, and then this, right? Like it's just gonna basically be this. I could wrap that in a macro here, and then these could just refer to that, right? And then I would only have one array instead of two. So I think I just keep it like that for now. So if I end up deciding that I don't want a multi-state map like this everywhere, I only need that specifically for the machine thing. I think one of the things I keep thinking is that now that we've got the ability to generate these data tables that are accumulated out of everywhere, that's cool. But the next step is sometimes you generate a data table with the idea that it's going to be like a key value map, right? There'll be several columns that work together as the keys and several columns that work together as the values, and then you want them in a map. And so the real power move would be to say, for each table you make, you can say auto map this, and then once it's fully done and working, that becomes an opportunity to optimize the map. The mapping could be optimized by something like a new kind of compiler, something like a new kind of code generator that looks at the data table and figures out the best way. If it's just a fallback, you could just have a hash system. But there's also opportunities here for like, okay, well, how many states are involved in this particular map? The encounter round, the encounter fight, encounter flee. Could end up being like 5 or 6. But if you look at it, you might end up finding that there's only, it's not even 6 times 6. It's more like, instead of 36 actual combinations, the full thing, the full deal might only be like 5 or 6 actual or if there are going to be 6 states, then there's probably going to be something like 7 or 8 combinations that are allowed, or something like that. Something like that. The point being, you could imagine arranging the IDs, like having a compiler whose job is to look at the maps between small consecutive ID sets and choose a representation, because the symbol sets don't actually care what the ID is for each symbol. It just cares that each one gets a small consecutive ID. So you could imagine picking them in such a way that it makes it as fast as possible to compute the map. And then it's just a matter of using the data table that's in the object file after the C generates it, running it through the computation that figures out the optimal computation and stick that in instead, right? And drop the data table. Or keep the data table, but keep the new function as the implementation of the mapping somehow. Generate a mapping either as a hash map that gets baked in statically, or as a computation, like it's some kind of switch optimizing system, right? You know, switches feel very similar in that sense. It's take a set of things, and sometimes you can optimize it all the way down to a jump table. Sometimes it's just a bunch of checks. And so I think the question is if in the meantime I want to be bogged down in rearranging this a bunch, or if I just like keep it simple, right? So I could just go, we're going to duplicate it. There's going to be a count. There's also going to be a is post, and then there's going to be a hook. And then what has to happen is these paired off ones need to fuse together into a different structure at init time that I handwrite for now because I don't have more static generation tricks. So vert, yeah, it's a lot of preprocessor stuff. The preprocessor stuff is all for wrapping these global variable declarations. So the global variable declarations just create global variables, but I'm using a dirty little trick to make sure that all of the global variable declarations that are declared behind a macro like this one end up in an array in the final program that I can get the base and count of programmatically, so that at main I can, in addition to having all these globals available, where is this? I can write code like this that just starts scanning through these symbol sets and building hash tables and other data structures on top of them. And so that's like, you know, I do these declarations, organize them into arrays with using a dirty trick, and then I can process it all into more rich data structures on init time. And if you want to see more about how I'm doing that, so the macros are for wrapping the dirty trick, basically. And then if you want to see more about my dirty trick, well, it's not public yet. But for my members, I put out the C scripting thing. And what is public is yesterday on my YouTube channel, I went through this. So let's not do it that way because I'm just going to pull up like random shit. There we go. So loud. So loud. Okay. I want to go over to, okay, if you go to the Mr. Fourth Dimension Archives channel, you can see right here, I did a big introduction to the C scripting concept. That's why all the macros, right? Now, the finite state machine piece is kind of true too. So I'm building, it's a little bit, it's compositional finite state machine. So each finite state machine is essentially a finite state machine, but they have different ways of sort of ports and connections to each other so that they compose, so that I can write small ones and link them up. And another trick going on there is that I've decomposed the since it's an RPG simulator, RPG as in role-playing game simulator, the state machine for the encounter actually decomposes each state into a pair of states, one for each party, and so there's a rule for each possible state pair, which is, since it's a sort of game theoretically symmetric, it doesn't matter the order of the states, right? That's what Maria was talking about. And then after each rule is processed, it has the ability to transfer each party to a different state. So it's like a state machine with a pair of states. And so technically it's still a state machine, right? Like a pair of finite states is a space of more finite states. But it's the language that it generates makes it very easy to do things like, okay, we're just going to go to a state based on the decisions independently made by two different players. And so one can fight and one can flee, or they can both flee, or they can both fight. And there are handlers for each combination. And then as I want to add in other things like, okay, fight, flee, what if you want to go past them? You don't want to get away from them, but you don't need to stop and fight them. You just want to get past them. Well, I've been thinking about that. There's like encounter pass or something, right? pass or go past or whatever. And so then that would engage another kind of thing where if you do this and they flee, then you get a freebie. If you do this and they also do this, you both get freebies. If you do this and they fight, though, then you got to either win the fight or generate enough speed to get past them. So you've got two different ways to deal with it, right? But that's a little harder than fleeing, since it's not fleeing away from them, but rather running through. They get more opportunities to mess with you. And so to handle all those different the combinatorial explosion of different decisions that can be made, I made this double dispatch system for the state machine. All right, onward. Rule symbols, rule proto, rule, define, RPG rule pre. N post dot 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 the. All right, now we want to grab this thing. Rule script states symbol comes like that. Hook signature, rule script, N. Rule script states array count, post. So this is just an initializer for this. States go here, count goes here, post goes here, and then the rule script hook goes here. Paging Turner, yes. So the new thing that what we're developing today is that it's a push-down automaton because we have a state machine we have a stack with a state machine on each level, basically. I mean, the additional thing is it's a push-down automaton, but it's also open, not closed, which I guess ultimately once it's compiled, it doesn't matter if it's open or closed. But the point is that it's open in the sense that you can just define new ones in by dropping new code in. It's not centrally defined. It's defined through it's declaratively defined over the space of the whole code base or the program or whatever, right? That's the scripting part. How will distribution for buying it work? So it's a great question. So if we're talking about the C scripting part, you can see it now. I'm iterating on it a couple times a week, like maybe Thursdays and Fridays. Although this Friday I decided not to. It is a research project, so it's incomplete, but it works on Windows in a couple of the combinations I've tested. You know, I just set up this new. I'm not signed in anymore. Hold on. Just take the card just real quick. Go back to here, and there we go. Okay, so I set up this new to-do list so you can see things that I'm thinking about doing next. I need to write more examples and usage code, but the basic idea is implemented right here in symbol set and symbol set define. You could start using it now on Windows if you wanted. If you were a member of the Mr. Forth Labs, if you go to mrforth.com and you get the membership, even if you just pay for it for 1 month, you get a license to use that code personally, just not to redistribute it. And that's how you can get it right now. Now, if you want the polished version, after all the vetting is done and after all the things are known and documented about how to fix the worst things that come up frequently with it, and the tool utilities for visualizing, viewing, and correcting mistakes and stuff like that. Once all of that is done, it might be a few months from now, it might be a year from now. I'm thinking I'll probably sell it as a package for somewhere between like 25 and $50. Maybe it depends on how much work goes into it, right? If I don't end up building a bunch of utilities and it's just some example code, then we're talking like 20. And here's the other thing you should know. If you don't want to buy the package, if the idea of buying the package sounds lame, there's two other things going on here. If you become a supporter or a member of any kind, every dollar you spend supporting the lab, you get a credit for, and you can just use that to buy it too. So like if you spent 5 months as a supporter or 3 months as a member, then you've already got all the credits you need to buy it, basically, right? And in addition to the separate C scripting one, I occasionally publish my code base, and my code base has another instance of it right here for free. It's tied into my code base, so it's not like it's not the full package of utilities, and it's not the sort of example code, but once in a while, and probably sometime by the end of this year, a free version of just the basic code will be posted again for the Mr. Forth code base, but it'll be all tied in. You'll have to, it won't be an example that's easy to work with. It's just my code base, so it's kind of very tied in on that one. So that's just what's going on right now and what you can look forward to with the C scripting stuff. Hope that answers all the possible questions. I'm also just want a disclaimer here. I'm not really committing to any particular model. This is what I have in mind, but I'm still working on it. I don't know when it will be ready. I don't know how much it should be priced at. And I don't know if it's actually possible to work out all the downsides to my dirty trick, right? Like I said, there's a little bit of a dirty trick that goes into making this work. And the research is in on iterating how to clean that up, right? How to eliminate all the downsides as simply as possible. And there are a bunch of promising options for how to do that, but I have no idea what, at the limit, it might not be possible, for instance, to get this to work on certain compiler linker combinations or something, or in the Linux operating system. I don't have the ELF version up and running yet, so you can't do this on Linux yet. There's so much stuff like that that isn't 100% there yet. So the other disclaimer is it's still a wacky idea. I think it's a great way to program, but it's still a wacky idea. With the full release, I haven't really decided how I'm going to distribute official software packages, but it won't be a repository. It won't be the same repository because it's going to come with, or it might be, but I don't think it would be repository access necessarily. It might just be a zip file. A repository access would be cool because then it's automatic. Like you can just pull anytime. That's not a bad way to distribute it. But I want to distribute at least the binaries for the utilities, right? The headers for creating symbol sets need to be source. But the utilities can be binary, and not having to build them could be nice because they're just going to be, tied right into my base layer. Like my code base will be the launch pad I use, the workspace I use, to build those utils. And so if you don't want to have to be able to build my whole setup, I want to be able to distribute the binaries. But maybe, I don't know, a paid access to the repository might be the best way to distribute it. I just haven't thought about it. P1GB, I can't link it. I mean, I can, but you won't be able to get to it unless you have access to this members only group on my Git, right? So the best I could do is you can go to git.mrforth.com to look and see if you have a membership, then you go here. And if you don't have a membership, then you go here. Right? There's your links. Another one of those really rough edges is this right here. There's this whole thing right now where in order to reference one of these symbols, you can do it as a pointer to the global variable, right? You can just say like, I want to access the global variable like it's a global variable. Or you can ask for its ID because they're packed into an array. So they generate a small consecutive ID system for the set. And that's on purpose. That's a part of what I want it to do. But that small consecutive ID system cannot be accessed until you reach main, right? So certain things, declarative things like this, need a backdoor for referencing them. So there's also this idea of raw references, which are not small consecutive IDs, which can then get converted to small consecutive IDs once you've entered main. But declarative code at global scope like this has to be done carefully right now, and that sucks. So that's another rough edge I haven't fixed. Yeah, and thanks. There's the VOD from the YouTube on YouTube. My VOD channel has the long conversation I had about it yesterday, so you can check that out. Okay. Right, and we don't want to have to name each rule. So that's where we go counter. Another limitation of C scripting right now, which I do not think is solvable, is that you can only put one hook in each symbol. And that's why I have to do this whole pre-post thing, right? So a part of what C scripting does feels a little bit object-oriented like, right? Like you have all these hooks flying around now. It feels like vtables, but the big difference is that classes do not bind function pointers to globally initialized data. They bind them to structs, which I think was the wrong layer. Like I think it's not as helpful as this. And so what you kind of actually want is something like the idea that you're going to go, like, I think it's more like you want to do, you just want lambdas, not even closures, just lambdas, and the ability to gather a set of declarations into an array at compile time, right? Because then what you would do is you'd be like, okay, my RPG rule proto, you still don't want a name either. Well, pretend you had a language where you can drop a name by doing underscore equals, and then you go RPG state and counter round, right? What you would really want is like this. This would be like raw states is an array like this, and pre is a hook, so lambda like this, and then you've got to like still put in the context or something. So like you could imagine a language that had the right pieces here, and then you'd have the ability to say when you're defining RPG rule proto, you'd also have something that's like gather into RPG rule symbols or something, right? So like just for all those language designers out there, this is what we want, right? Like this, and then like this or something. You know what I mean? I mean, it'd be nicer if you didn't have to do this whole bit, right? It'd be nice if you could just go dot pre, and since it's a typed function signature type already, like it's already it's already got a function signature in its type with function parameter names, right? So then it would look like this. So you can see how it's almost C++ like that. You define each function. But then you also bind global data, and you aren't making a class. There aren't instances of this thing. There's one of them. And so what this really is it's sort of like, imagine if C++ didn't have invisible vtables, but instead just gave you a way to manually program your own vtables. You know what I mean? I think that's a good way to think about it, maybe. What are we missing? There. Okay. Something like this, although this clearly is starting to show the need for a type that represents these things together and can be moved around and allocated and deallocated and stuff. Oh, Sebby, what do you mean by static initializers? But this is the part of the system I don't like. The fact that I have to sort the party state array. Right. So the two big differences that you can't get with just static initializers, you're right. It is basically just I'm saying we should have static initializers in the language, and we do. Like C has static initialization, C++ has static initialization. What's missing is the ability to gather the statically initialized data into a single data block and into a single array, and then to make each of those symbols, or to arrange the symbols so that they each get a an ID inside of a small consecutive ID system, right? If you have 20 of these things declared in the global scope, great, but how do you find them all? The way I'm proposing that we find them all is that you put them together into an array where you can get the base of that array and the count for that array as soon as the program starts without any additional registration work. And the way you reference it and deal with them is through IDs instead of pointers, so that they don't have to be 64, but they can be like if you have 20 of them, you could use a byte to represent every one of them, right? I use U32s here, but I don't have to. I could be using U8s right now because I don't have 255 states. But I'm just thinking like, hey, I don't think that this is not where I think the performance is going to come from. So I'm not worried about it in this case, but it's an option now because once they're all statically initialized and arranged into an array, they also automatically have small consecutive IDs. And I feel like it's whenever you have a system that where important concepts are already tied into small consecutive IDs, there's so many cool things you can do to optimize the data structures for keying on those and accessing them and attaching data to them. It's kind of great. So if you just improve static initialization to gather the initialized data into an array and create some kind of syntax for referencing each of those symbols as either a global variable or as a small consecutive ID, or as like the small consecutive ID for the symbol you're trying to reference, then you got it. Yeah. Why do I have it on the clipboard wrong? That's weird. Oh, Sappy's next idea. Yeah, so you could do an X macro, right? The idea is somewhere between global variable static initializers and an enum, because an enum is a small consecutive ID generator. But the problem with the enum, there's two. The first is that you separate out the locations where you define a single concept. Now, sometimes that's super appropriate. Sometimes there's a couple of key concepts, and they're going to need to be referenced in lots of ways, but they're not likely to grow, right? There's going to be, you've got a protocol you're implementing, there's 5 of them, you got a file format, there's 125 of them, whatever it is. Once it's sort of set, and it's not changing all the time, you're not iterating on it, then it's not such a pain to use an enum. But with stuff like this, it's kind of a pain, and it's a lot easier if you can declare a new value anywhere in your code. and have it get added to the small consecutive ID system. So part of what happened here was I was thinking of these two things separately and discovered that the solution of them go together, right? There's the small consecutive ID systems are awesome. And there's also the ability to organize data and functional like function pointers together more richly is useful. And the ability to turn that into data structures you can work with without having to manually register it, right? And it turns out that the solution to both is the same thing. It's a symbol set. Like it's kind of just, I don't know. I'm excited about it. It lets me do cool stuff. I'm hacking it into C right now, and I'm gonna have to do some steps to refine how it works in this case. But it's really not that far off from what every language that is C like already has to do. So and the way I'm doing it, it might not be possible in languages whose compilers don't have a little bit of extra, like, compiler extensions piled up over the years for things like manipulating data sections, which is what I'm doing. Um, so it's not quite to the point where I can just say this isn't even really about C as much as it can as just a pattern you can apply to any object file. That's not entirely true because other languages might have properties that interfere with this or don't or lack the compiler support for it. But the idea is you just organize the structs into a separate data section so that they are next to each other, and then access that data section at the beginning of the program. Roughly speaking, obviously with compiler support you wouldn't even need data sections, but I'm just saying it's so on the surface. It's almost already there in a C-like language, but it's always just slightly not convenient, and that's why it's kind of exciting to have it working now, because it has just eliminated a class of, or it's helping to eliminate a class of problems. I'm still working out the kinks. Okay, attack is no longer a move kind. Late attack is no longer a move kind. We're gonna replace those concepts a little bit with an idea of move speeds. That's at the level of the game design, though, not at the level of the architecture as much. Although at the for the RPG simulator, they're the same. Essentially, it doesn't touch any of this machine state rule system stuff, though. That's the tiles and the moves. Yeah, none of this exists anymore. Chase operators exist, but they're not really real. They're more placeholder. I mean, the encounter context subcontext is just a dummy. The reason I'm structuring it this way is because I can imagine that I don't want to actually do it the way I'm doing it, but I don't have the sophistication quite yet to solve it, because while all the static stuff can very easily be given small consecutive ID systems with all the C scripting, an entity system is still an entity system, and right now I don't have small consecutive IDs or any kind of data structure for mapping stuff onto entities. So I have to kind of cheat a little bit. But the better the engine gets, the more easily a lot of these things will be done. Subcontext clear. Where is that? So these don't exist anymore. We're done with those. We're done with these. And this is where we call it. We are now ready to go and rewrite the main loop. I need a snack. Okay, I'm going to take a little breather because I've been chatting a lot. and mute, listen to the music, and mute my microphone and snack on my robin's eggs and my chips for just a minute. I'm gonna chat with you in a sec. It's an interesting topic, and I'm curious what your issue with the Unity build is. There, super. But before we get into it, this reminds me that another thing I should mention about the C scripting system that isn't figured out yet is how it would play with DLLs, hot reloading, and plugins. Something like this would be super, super awesome for a plugin system, right? Like with 4Coder, I had the 4Coder commands. They're basically a C scripting system, but they were C scripting without me having this symbol set code. Like I hadn't built this structure yet, so it was extremely heavy. It was a meta program. Uh, it relied on a number of carefully placed assumptions that usually don't cause problems, but are lurking there like little time bombs. And this is a lot less. There's no meta program. It might have a post processor to the object file. In fact, I think it needs to have one in a final production version. Because the data sections, when you make a separate data section and add, it allocates them at a granularity of 4K, 4K pages for each data section, and you don't need that much memory for most of these symbol sets. So putting them all together into the data section is the right way to do it, I think. But since C doesn't have a feature that does this, what I'm going to have to do is post-process the object files in order to remove that pessimization. But then the second problem is statically built small consecutive ID systems are great, but dynamic linking adds a wrench into the system because now each DLL will have its own small consecutive ID system for each symbol set, even if they are DLLs that are meant to be plugins of the same sort, right? So if you drop in a couple plugins and each has 5 commands, they're each going to number them 1, 2, 3, 4, 5. And so you don't have unique IDs for each one. You have a unique ID for each one, given that you know which module you're talking about. And so I'm going to want to spend a little time working out the best way to do that too. Okay, so your problem with the Unity build is that since you're targeting a single C file, right? When you have a Unity build, you target a single C file and it includes everything else, right? That's like what I have up here. So instead of building each of these C files, I'm just including them into the Unity C file, and I build the one C file. And so for you to have an automated build system you're doing the thing, and I've never built one of these because I don't like using stuff that works this way, if I'm being honest. But I know at a certain scale it becomes hard to get away from having a tool like this. So the idea with stuff like that is you target one of these Unity build files, and then all of these files are included, but then these probably include things. So there are dependency graphs of files happening here. It turns out that the only thing you need to be able to do is to create a list. Whenever you build, you need to create a list of all the files that were involved in the build, right? If a file was included, then you need to know about that file, and if any of them change, then the build needs to be rebuilt, right? That's all there is to it. So my recommendation is you run the preprocessor only, right? You can construct or you can have the compiler run like you normally do, but tell it to stop after it's run the preprocessor. Okay, let me show you what happens if we do that. Let me just see here. RPG simulator. Okay, it's just gonna take a minute to make an example here, but this is kind of a cool trick. This is maybe gonna help get. This is the best way I know to get precise information about what's gonna happen when you build your program. And that's to build it. Right, so if you want to know what happens when you build your program, I recommend you build it. And so we're going to do Scratch. Ooh, this is old now. Thank you for helping me earlier today figure out what I want to do. This is what we want to run, right? But this is the wrong one. Build it again. I turned off diagnostics already. Okay, build it again. Not that one, but this one. CL on the RPG sim -C -II da 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 da. Okay, all of this is good, but what we're gonna do is we're gonna go. Let's see. CL flags preprocessor only. MSVC compiler flags. I think it's /P. It looked like preprocess to a file. So if we take this and we say, hey, I'm not trying to build an object file here. I'm actually just trying to preprocess it, and I want you to see now. Let's see. This is going to be under source/new/RPG sim. Oh, right. So the syntax is off because the other script runs in the Unix on the Linux on Windows stuff, or rather, it uses git bash. There we go. So I should have right here. Yeah, there we go. Let's check this file out. If we come over here now, we have this file. Now this file is going to look crazy because this is a preprocessed file. So that means it's doing things like erasing the comment lines but not removing them, not removing the blank lines. It's expanding every header file. But look at this. It's going to give you the list of all the files that were involved. You see what I'm saying? You're going to find all of your lines. You're going to look at each line. You're going to ignore the number and see the string. And that's going to be precise. That is literally what the compiler found during the pre-processing phase, all the files. I need a new song. Can we get something that, like, slaps? How long till this song slaps? That'll do. Okay, main loop. That's what we're about to do. Took me a minute to remember. Okay, so I think these need to I think these need to be baked into the machine frames actually. So a machine frame is going to know how many parties there are. It's going to know all of the entities, all the parties there, and it's going to know their states. Okay, so it's not going to be like this. It's not going to be like this. What we ended up with was this needs to do an RPG call to encounter. So call the encounter machine. Give it two parties, party 1 and party 2. Then what we do here rule pattern. Yeah, so I think what needs to happen what needs to happen is there's going to be a machine frame at the top of the stack with a current array of parties and party states. That needs to get copied into this one and then normalized like before. So normalize is just going to do the same thing it did before, except instead of using the one that's here, it's going to copy it in from the top of the machine frame and then do what it normally does. Right? That's the same. And then I guess I'll do these the same. It's all a little bit cruftier than it needs to be. It's heavy duty, like overcomputed, but we can fix it some other time. this is like once per iteration. There's going to be much heavier stuff happening in the guts of the rules and in the guts of the simulation. But at some point, this is still overkill, and we could shave off a couple percentages of waste by fixing it. However, for now, let's just do that much. And now that we've got the reminder, we look at state array normalize. And we say before we do the recursive normalization step, we're going to do machine frame we get out the machine frame is 0. So here the machine frame can be asserted to be not 0. And then we memory copy array the machine frame P into the context P and the P state into the P state, and then the P count is the P count. Okay. So you make the call to set the thing up. You check the frame at the beginning of each loop. You normalize. Look up the rule for the pattern. Still the same logging. The logging might need to change over time. Like, this isn't quite right necessarily once we start thinking about having like the fact that there's a stack now. And so you might want to know what machine you are on as well. But we'll get there in pieces and pieces and pieces. So if you don't have a rule, you exit. That's not true anymore. Let's pick up right here in 5 minutes. All right. There we go. There we go. All right. Be back soon. All right. We're going to try to wrap this up. I just want to get, for now, my checkpoint is to just get combat going again. The journey will still be non functional. It's kind of ambitious because I still have to write the call system that pushes machine frames down and initializes them through the machine definition hook, which lives right here. So this is gonna need, I'm gonna need to set up to be able to run this. This isn't even right because we're not gonna keep p count around anymore. Um, it would be like that. Right. Because the context isn't going to have that P array until after the normalization phase, so it's not really the same anymore. Let's say so. Yeah, we got to do implement the call for the frame thing, and then this, which is when there isn't a rule. Well, it's a little more complex than just that too. Um, um, here's the conclusionary logging, but then if there's not a rule, that doesn't mean we're done. That means we pop the stack. And really, we don't have a full stack, and we don't have the return handlers. So this would be where you do, this should not happen, or let's just do break, because it's still going to happen. This is where we should do pop the stack, run a return handler, and run the return handler, or exit, right? So if the stack becomes empty, right. So what happens here is you go, we're just going to do it now. If context machine frame, let's do RPG machine stack pop context. If RPG machine stack empty context, then you break. That's the same thing as what we have up here. Here we go. Now, kind of feeling like I'm getting close to dinner time. I haven't had food. I'm gonna have to wrap this up soon because it's just the end of the day on Friday. I don't want to be here for more than another 30 minutes or so. So I'm gonna need a little bit of pop-off style music. So right now I have to do stuff like this in order to put two hooks into the same thing. Hmm. Yeah, I really don't like the whole permutation thing. I'm just sitting thinking about that for a sec here. Having to swap these around over and over again. There's so many different spots where it happens now. There's the spot where when you call the machine, it stores the array of parties, and then you initialize the state for each party, and then when that gets normalized, it doesn't affect the machine frame. It just affects the one that is used for dispatch, right? We use the normalized version to dispatch, and then we unnormalize it to permute it into the order that matches the interface of the code, right? The one that the order it is defined in the code, so that the order you write it down in the code matches the indexing order of the parties, and you don't have to like figure out which one is which manually every time or anything like that. So great, but then what do you do when you want to modify the states? Well, what you do is you correlate each new state with a party through the current order and map that back. And so what you would need is some kind of additional like permutation step that takes this and repermutes it after by looking at the unsort the with the index the other way around, right? You can when you have an unsort, you can use it both ways. You can use it to go both ways, just by moving it from one side of the equation to the other, right? There's ways to do it. So let me think. The issue with all this, though, is that first of all, it's so much work, and second, like it's confusing. Machine goto gets called in the middle of a rule script, and so there has to be like an already known mapping between the the rule local order and the machine frame order, which is actually not something we have, because when we normalize it, we throw away the original order as if it doesn't matter to us. So that would need to get rewritten completely to make it work. Now, after doing this for a while, I'm starting to get the idea that what really needs to be happening is that the states need to be inside the entity struct, because then none of this would be a problem. Whatever order the parties are in just needs to match at the time you call the rule local order, but then to modify the states of the parties, you would write them into the struct itself. The only problem with that is that if you start doing it that way, where do the states go for other machines up the stack, like down the stack, right? If I have a journey and I'm on my journey state, and then I get into an encounter, and so now I'm in a fight state, and then I exit that, then my return handler goes, and it should know where I should transfer to next. But there's just something a little funky about the fact that the states are thrown out like that. And then recover. I mean, it works. So maybe it's not a problem. Maybe the entity just needs to keep track of the state that it's in for the current top of the machine stack. And when you pop, the return handlers don't. It doesn't even matter if the entities that were in play in the before the pop are still in play. Like the entities could be completely unrelated or related, but not the same ones, and it should just work, right? Like you should be able to pop, and the return handler will decide what states we go to next, which then just writes those states into the relevant entities for this level. And so an entity just always carries the state relevant to the last time it was at the top of the stack. I guess where this falls apart is when I start wanting to have these go in parallel. Right now I'm only having them run as stacks, so there's only one thread, so to speak. But I do think we're going to want to be able to make incremental progress. At some point we're going to want to be able to have one of these machines make incremental progress through its space of states, but suspend it, right? It might decide, like it'll say that it has completed a part and then suspend itself. I don't exactly know how that'll work and if it would be a problem or not, but I could imagine a problem might arise there where the restore now is more complex because we're gonna have to like usually the states are on the entities, but during context or basically a thread swap, if there are multiple storylines, multiple state machines that can be in flight, and then one can be suspended so that other ones can make progress, which just plays out as different scene cuts or something like that in from the perspective of an RPG interface. That's going to need to be then handled as a data structure again, anyways, mapping entities to states and storing them for restore later. It's a mess. It's a mess. I think I'm too hungry and it's too late on a Friday to solve it. But this is what we have to start fixing up now. The machine stack is going to work, but it's not going to work because once I'm going to just make it work for now. I'm going to hack it however I have to, including by changing the order that I declare them in, right? I'm just going to forget about the whole permutation concept and just hack it and leave a note that says this doesn't actually have a formal, reliable uh, uh, solution right now. It has to be manually micromanaged to make it work. But we'll come back to it and get it right because there's something super off about it because there's so many layers of reorganizing happening all the time. And for different reasons. I think a big part of it is just that it's just not that interesting to have this double dispatch be so primary. And probably what we'll do is we'll just go to a system where each rule is considered a state, and the multi-dispatch of two parties in the encounter will be solved a little more locally somehow. So what we'll have instead is an array of parties that are in play and a state. Well, I still need to know which party is which somehow. Having the states on each one was how I was doing that. If it becomes like the order matters, then I kind of just introduce the problem at a different level, right? Because then you have to look at your current array and keep moving it around. And I kind of want to be able to get to the point where the array of parties stays the same and the states are just changed. And then whenever you call a rule, the accessor to the parties is laid out in the syntactically correct order somehow for you to know, so that they're in the slots you expect. Maybe that part's the part that goes. Maybe what happens is that you manually pull out entities by their state. So if you have an array of several entities that are in play, then and you want to ask. Well, another thing is there might be multiple entities in play that don't all have states in a final version of this, right? Like, it's super possible that the best thing I could do is just have an array of parties in play and a single state, and then encounter in particular has this problem that I want to solve that is tracking a state for two parties, but then a lot of stuff might have more than two parties in play but not a state for each one. I don't know, though. I had a lot of ideas that I haven't explored yet that would involve multiple parties in play beyond two, with each of them having a state. I think that's a pretty deep assumption in how I think about things, is that these parties have states. It runs deep. But they have states relative to a particular context, right? Oh, man. Yeah, something to solve for another time. Okay, we're close. So now what's happening is we when we run the preamble, it generates a list of decisions that need to get made, and then the brains need to run and the moves need to run, and I think I'm out of time. I just don't think I can do this much. I think that's about as I was planning on getting all of that done. I forgot about the change to the decisions and the change to the brains and the change to the move execution. So we're halfway there, but we're not running yet, which means that's what we'll do Monday. Monday we'll get this running, and then I don't know what else, but Monday it'll be easier to figure out because I won't be hungry and tired at the end of a Friday, right? So we're just gonna end half broken. It happens. Cool. Honestly, I feel like I got a bunch done though. Even though it's only halfway there, the rewrite of the rule system seems excellent. Like it seems like that was the right move. This idea that I have a pre and post amble, and that the main loop is gonna just handle player decisions and a core move resolve that is the same across all rules and machines in the simulation, but that the preamble sets up what decisions need to get made, and the postamble does additional post processing, additional state flow control. And there's the stack. All of this is super cool. This feels right. It feels like if I push this a little farther, I should be able to now create a journey and then jump to encounters from it, and then start populating those encounters with pulling them from a deck, like an encounter deck. And I should be able to start building other stories other than the journey as machines as well, and they should start being compositional. It feels like it feels like this is all going to work. So the next question is like, when you finish a journey, what happens next? And the first version is just, here's a fight, and if you win it, you win. Then here's a journey, and if you finish it, you win. And then it's if you here's a journey that concludes with you arriving somewhere else, that then gives you a choice. Like you can start to see how each of these layers can compound, and we can build more and more interconnected sub games this way. And I don't know how fast the simulation can run at this point. It's been a while since I looked at the profile, but my vision is to be able to describe clusters of sub games that interrelate, and then compile them down to code that can simulate them as fast as possible, so that I can do stuff like gather statistics on how different types of characters perform against each other and perform against different challenges in these various plots that I can place them in. And then if that's all up and running and working and the expressions for it are correct, then it'll be time to start optimizing, right? Once I can express that, which it feels like it's right around the corner now. It feels like this gets fixed, the journey starts working, maybe we do a wilderness one and we do a battlefield one, and so then you've got several metagames that can contain these encounters, and then we generate several other types of encounter modes and we fit those in to the encounter system we already have, and now you've got so many different interrelated sub games that you can already see right there, and the possibility to build out more is just a matter of the typing and the debugging. I think at that point it would be time to optimize, get the tile board ready, and finally get out of the part of the RPG simulator where I'm really, really doing the RPG simulator a lot right now, and switch over to the part where I'm testing out the separate DLLs. Because this is the contact with reality that I need for my base layer, my code base, and my symbol sets. And I just want to get there after having actually built the entire core language properly. Because if I start splitting things out into DLLs and trying to make a expansion system for the simulator, before I get the language right, it's going to calcify, right? It's going to, DLLs are so much extra maintenance. And hopefully the C scripting will make it possible to simplify, but I don't want to assume it can go all the way because there's some like hot reloading, the state IDs might change between things. So like there's all sorts of stuff. So it's cool that we're getting there. Yeah, I think this wasn't really this yet. We're actually just complicated this, but we're gonna do that. We're gonna fix this next week, and then we might be able to do condition clauses and tile boards. If I spend all week on RPG Simulator, I might also just do a couple days of streaming like I did this week. And like I said, I do have this other elements that I am working on, which is to get some visualizations ready for this system. And so I might be on or off stream doing a little bit on this as well. But that's what we got going on. And of course, there's also the C scripting thing. I'll try to do some C scripting iterations whenever something new comes up. But I can't quite promise that I'll do it next week just because I'm not sure what's next with it. Like, the next big stuff is all really big. Like, I need to write the ELF parser. I need to condense the PE parser. I need to then make a condensed version of the ELF parser. I need to work on all these binary utilities. This is a separate project for improving the C scripting. And doing it in small steps might be wrong. I think it might be better to just test out this DLL problem first before I go all in on all the other utilities and stuff. But on the other hand, if I come up with an example, right, there's also just example writing to do, and there's more to do to clarify issues that come up with it and stuff. So there might just be some writing to do with this. So I don't know. I'll work on this next week too. As a reminder, if you're into the RPG Simulator or the C scripting projects or any of the other things that I've worked on that I might bring back, which you can always go over to MrForth.com software and see some of the kinds of stuff I've played with and some of the stuff I might play with in the future, is implied software. Here you can go check out some of the other projects I've talked about working on. If you want to help me to succeed at working on any of these, or if you're looking to get your hands on the code for the C scripting before I'm finished vetting it and start playing with it yourself, think about going to MrForth.com/membership and maybe becoming a supporter or a member of the Mr. Forth Lab. And with that, I'm going to sign off for the night and for the week, and I will see you all around the internet. Bye-bye.